6.3 Further Log Properties. So we're going to go ahead and talk about some properties of the logarithm. We mentioned some basic ones before, so I guess you would call these the more advanced properties of the logarithm. So, introducing our log properties, we have the first one, which I'm calling the logarithm product rule, which says if I take the logarithm of a product, x times y, then this can be rewritten as log base a of x plus log base a of y. So it looks like I'm changing product into addition. On the other hand, for my second rule, the quotient rule, if I take log base a of a quotient, x over y, this can be rewritten as log base a of x minus log base a of y. Notice that here I have minus, before I had plus. And then my last property is the log power rule, meaning that if I have log base a of x to the r power, then I can take the power and move it to the front, giving me r times log base a to the x power. One thing I want to note about this particular rule is that to move my power, it has to be the entire expression inside the logarithm to that power. And you'll see what I mean in a little bit. One other thing is that these properties apply for all logarithms, so the common logarithm and the natural logarithm as well. So let's go ahead and do an example 1. Let's expand some logarithms as much as possible. And I want you to simplify anything that can be done by hand without a calculator. So for part A, I have log base 4 of 5x. Well, what I'm going to notice here is that I have a product. I have 5 times x. This tells me by my product rule that I can write this as log base 4 of 5 plus log base 4 of x. So I've expanded this logarithm, and furthermore, this can't be simplified any further. Log base 4 of 5, there's nothing I can do there. Log base 4 of x, there's also nothing I can do there. So I'm done for part A. I expanded the logarithm. For part B, natural log of x times the square root of y. Well, the first thing again is I notice that I have a product here. If I have a product, that means I can rewrite this as the natural log of x plus the natural log of the square root of y. And I can take this one step further. Remember, natural log of x, I'm not going to do anything, but a square root can be written as a 1/2 power. That is, I can write the square root of y as y to the 1/2. Now with a power, I know from my properties of the logarithm, I can take a power and move it to the front of that logarithm. That is, I can make this into 1/2 natural log of y. And then I'm done expanding because I don't have any more products. I don't have any more powers that I can play around with. And I don't have any more quotients. So now, let's go ahead and do part C, our last one for expanding. Notice here that I have multiplication and division. So, in this example, I'm going to go ahead and actually do a couple of steps at once. I'm going to go ahead and write this as log base 2 of x plus log base 2 of x squared plus 1. So I have this here. I got plus because in the numerator of this expression, I had multiplication. And then to accommodate for my denominator, remember a quotient, whatever is on the bottom, becomes subtraction, giving me log base 2 of x minus 1. So I have this new expression. And actually, I claim that there's nothing else that we can do here. If I look at my first term, log base 2 of x, there's nothing that we can clean up. There's no products, there's no powers, there's no division. For my second term, you may be tempted to say, doesn't this have a power? Why can't I move that forward? Again, I'm not allowed to move the power unless it applies to the entire expression. In other words, if I had log base 2 of x plus 1 squared, then yes, I would be able to move the 2 forward. But in this case, I don't. It's only applying to the x squared. It must apply to the entire term. And then my last term, minus log base 2 of x minus 1, again, there's nothing we can do here for the most part. And actually, this is as simplified as we will go. Thus, we are done with example 1. Now, let's look at example 2. For example 1, we expand it, but what if I asked you to compress each expression? So, using the properties of the logarithms, write each expression as a single logarithm with a coefficient of 1 and with positive exponents. In other words, I don't want anything like 4 log of whatever. I want it to just be a logarithm or a natural logarithm of a single expression. So for part A, I have log base 3 of 16 minus log base 3 of 8. Well, I see this subtraction right here. That tells me whatever is being subtracted should go into the denominator of a fraction. In other words, I know that this can be written as log base 3 of 16 for the top over 18. If I simplify this, I get log base 3 of 2. And then from here, I don't have any common bases. I have a logarithm with coefficient of 1 and no negative exponents. So I'm done with part A. For part B, 2 log base 5 of A plus log base 5 of B minus log base 5 of C. So the first thing I'm going to do is I'm going to get rid of any coefficients. In this case, the only coefficient I need to move is my 2. This becomes log base 5 of A squared, using the fact that a coefficient can become a power and vice versa, plus log base 5 of B minus log base 5 of C. So the first thing all I've done is move that coefficient and made it a power. And if you wanted to do this step by step, I can go ahead and say, all right, for this first portion, this is a log base 5 plus a log base 5. That tells me I can change this to be a product. In other words, I can change this to be log base 5 of A squared times B minus log base 5 of C. And then subtraction tells me that I should change it to division, giving me A squared B all over C. Thus I have my final expression. Again, my logarithm only has a coefficient of 1, and I don't have any negative exponents. Now for part C, let's see if we can do this all in one step actually. I have log base 5 of x minus 4 minus log base 5 of x minus log base 5 of 9. Remember, a minus means that these terms should go in my denominator. So I can write this as log base 5 of x minus 4 for my first term. Since I have minus, then I should divide it by x and also divide it by 9. Or in other words, divide it by 9x. Again, since I had subtraction in these terms, it told me that 9 and x should go in my denominator. And again, I'm done because my logarithm has a coefficient of 1 and I don't have any negative exponents. So we're done with part C. Now for my last type of formula, I'm going to call this a change of base formula. If you have a standard calculator, like a TI-83, 84, or a base scientific calculator, you'll probably notice that it doesn't let you type, for example, something like log base 5 or log base 8. It only has a log button or a natural log button. These are typically on the far left of the calculator, somewhere along the lines of, I think it's actually on the very far left near the bottom left corner. So how do I actually check the value of a logarithm that doesn't have base 10 or is not a natural logarithm? Well, since they don't have the option to specify the base of a logarithm, we have this change of base formula, meaning if I want log base A of B, this is equivalent to writing the natural log of B over the natural log of A, or if you want, you can use the common logarithm, log of B over log of A. You end up getting the same value in either case. So in example 3, I want you, if you have a calculator available, evaluate the following logarithms and then round to the nearest hundredth. For part A, I have log base 7 of 100. If you are able to change the base on your calculator, then this might not be as necessary for the change of base formula. But for the most part, most people tend to not have a calculator that lets you put in the base. If I look at part A, in your calculator, you could type this as natural log of 100 over the natural log of 7. Or you can also use log of 100 over log of 7. You get the same answer in any case, as long as you're consistent. So if you type this into your calculator, you're going to end up with something along the lines of 2.37. So make sure that if you're using a calculator, that you get something that looks like what I have here, about 2.37. So that's how we work on part A. What about part B? Well, for part B, we're doing the same idea. I can write this as the natural log of 14, or if you want, you can use the common logarithm. It doesn't particularly matter. Over the natural log of 1/3. If you were to input this into your calculator using the natural log or the common logarithm, you would end up with a value of approximately negative 2.40, rounded to the nearest hundredth. So make sure, again, that you get these values. It can be very useful, especially if you're trying to check solutions or get a better idea of the magnitude of your answer. All right, so that's all we have for this video.